my name is Sandrine Roulland. I am a research director at INSERM, working in Marseille in France. And so my objective in the QFL project is to understand what are the CPC or Common Precursor Cells and how they will give rise to the relapse for follicular lymphoma.
So my name is Karin Tarte. I am working in Rennes in France. I am an immunologist by training and I am involved in the QFL program working on the interaction between the microenvironment of follicular lymphoma and the cancer cell. So in the QFL program, we are very strongly interested by what happens in the patients when they are treated and when they are put in remission, because we know that at that time, all of them will ultimately relapse. And we like to know, when they are responder, what is the residual niche and how this residual niche could support these cancer persistent cells that will give rise to the relapse. For that purpose, we analyze the bone marrow of patients collected before treatment and after treatment when they are in remission. And we analyze by a strategy that is called single-cell RNA-seq, their tumor cells and the microenvironment in the samples to understand how they could interact with each other.
So the second part of the project is really to be able to target this interaction between the CPC and the microenvironment. And for that, to do this targeting, we are using mouse models, which are recapitulating the follicular lymphoma disease. And we are treating the mice like in the human with the therapy. And we are looking how we can target this interaction at the residual stages. I think what I think is exciting is that we are entering by looking in human samples. We have been able to characterize the residual, the persistent cells at the functional level. So for now, what we know is what mutation they have acquired, but we don't know really what they express, how they can be targeted. And I think now, with this project, we will be able to characterize and to find target and to be able to target them and eventually to eradicate and cure follicular lymphoma. And so I really excited by this phenotypic characterization of the CPC.
And for me, I am very excited by this project because classically in follicular lymphoma research, you have people working on the B cells and you have people working on the microenvironment. And they are not really interacting with each other because it's different specificities in terms of tools, in terms of expertise. In this project, we are working really all together to try to understand and to target this crosstalk. And this is very exciting for me because it's virtually impossible to have all the expertise to analyze everything. But if people are working together, then we are able now to target that and to be efficient to try to eradicate follicular lymphoma. With this project, we have identified things that are completely new to treat the disease. First, we have potentially identified a new therapeutic window that is until now not tested at all. When the patients are in remission, classically, the clinicians are waiting for the relapse to treat them again. And here we have identified a moment where the patients are supposed to be in remission, but here we know that there is some residual cells that will see the relapse. And so we think that we have really identified a new therapeutic window that could be relevant. In addition, we have also identified new potential therapeutic targets because we have now identified some mechanisms explaining the interaction between the CPC, the persistent cells, and their niche. And this could open new therapeutic opportunities to eradicate follicular lymphoma.